So you can actually do this if you have, just a fractional equation. Like if you have 1/2 plus x equals 4, you can multiply everything by your common denominator of 2, get rid of your denominators, and solve. When you look at something like this, the denominator then of your x is just what? What's your denominator of x? Any whole number over 1, okay? So then the only denominator I have here really is this guy. So I'm going to take this equation, I'm going to multiply everything by my common denominator, all right? So I'm going to say x over 1 plus 6 over x minus 8 equals 0. So my common denominator is the x minus 8. So I'm going to take and multiply every single piece of this by x minus 8. I can multiply this by x minus 8, this by x minus 8, and this by x minus 8. Every single piece is multiplied by your denominator, okay? So over here on the left, I just distribute my x. So x times x is x squared. X times negative 8 is negative 8x. Here, I can cancel, right? And that is your goal. When you multiply everything by your common denominator, your goal is to get rid of your denominators. So here, these guys cancel. And I have just the plus 6. And then 0 times anything is just 0. All right? If I could factor, I would factor. But there's no factors of 6 that add up to 8. Like 1 and 6, 2 and 3. They don't add up to 8, okay? So what's my other way of solving a quadratic equation with equal to 0? Quadratic formula, all right? Quadratic formula is negative b. My b is already negative, so I'm going to say 8 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, simplify that. You're going to get 8 plus or minus the square root of 64 minus 24 all over 2. Just keep simplifying. All right, you do want to simplify this 40, so use your factor tree.
I don't like that.
Do you have to do that?
Do you not know how to factor?
I do,
but I just...
Remember with the square root, if it pairs up, it goes out. If it does not have a date, it's single, it must stay in. Poor lonely little thing. So 2 can come out. He is single. He is single. When they're both single, they stay in, and you multiply. 8 plus or minus, okay? Here's the deal. To reduce it, you have to reduce every piece of it, okay?
So why is it?
Right, so you can't reduce anything with what's inside the radical. He is a square root of 10, he will stay that way, okay? But if I can take a 2 out of both of these, then I will. So 8 divided by 2 is 4, 2 divided by 2 is 1. All right, so this is my answer. It's really easy when you have one denominator because that is your common denominator. When you have something like this, you need to factor everything on the denominator that you can, all right? So the first thing I'm going to do here is I'm going to factor this. Factors of 8 that add up to 6. What are they? Yeah, so this is going to factor to x minus 2, x minus 4. This cannot be factored. It's just x minus 2. This cannot be factored. It is just x minus 4. To get a common denominator, you have to use each piece at least once. Now, if you had repeating factors, like let's say this was x minus 2, x minus 2, you would have to have it twice. Like if one of them has it twice, you have to list it twice, okay? But you just have to list each piece once, as long as each of them has it just once in there. So if I'm trying to find my common denominator, I'm going to say, well, I have to use x minus 2. All right, which takes care of that and takes care of that because I've used his, all right? I have to use x minus 4, which takes care of that and takes care of that. If I had a repeated factor, I would have to repeat it. Do you hear me? So not if it's repeated in something else, but if it's repeated in the same term, then I have to list it twice. But if it's in this term and that term, I only have to list it once. Okay, does that make sense? Okay, so this is my common denominator right there. That's my least common denominator. So I'm going to take this and multiply everything by it. All right, so I'm going to rewrite this. I'm going to say 4 over, and I'm going to write that in factored form. So I'm going to say x minus 2, x minus 4. That's what he is, right? Equals 3x over x minus 2 plus 2 over x minus 4. I just rewrote it in factored form. I'm going to multiply everything by this common denominator right here, okay? So I'm going to say multiply this by x minus 2, x minus 4. Multiply this by x minus 2, x minus 4. Multiply this, I'm going to scooch him over because he's kind of in my way there. Multiply this by x minus 2, x minus 4. All right, everybody see that? I multiplied everything by x minus 2, x minus 4. Then I'm going to cancel before I do anything else, okay? So this guy, the x minus 2 and the x minus 2 cancel, right?
Yeah.
The x minus 4 and the x minus 4 cancel. What am I left with?
4.
4 equals. What cancels for the next guy?
X minus 2.
X minus 2. I'm left with 3x and x minus 4, right? Plus, don't forget your plus.
Okay.
What cancels here?
X minus 4.
And I'm left with 2 and x minus 2. This must be a much easier equation to solve, is it not?
Oh, so it's not a fraction.
So now I'm just going to distribute and solve, just like I would.
It's not a fraction.
It's not a fraction at the end. My goal is to make none of them fractions. That's why I'm multiplying everything by my common denominator.
Basically, if you get a fraction.
Distribute, and then we're gonna simplify. All right, so I'm gonna distribute this through. So I have 4 over here, 3x squared minus 12x, distribute my 2, plus 2x minus 4.
Why wouldn't it be 3 cubed?
And then, so let's simplify. We're gonna combine our like terms here, and I'm gonna make this equal to 0. So I'm gonna move my 4 over. Okay, so I have a 0 here, 3x squared, negative 12 and positive 2 are what? Negative 10x. And what's negative 4 minus 4? Negative 8.
Equals
Right.
0.
Set it equal to 0.
Do you move that equal?
All right, so you can do quadratic formula if you want to. This one is factorable, all right? So if you'll remember how to factor, all right, I take my 3 times my 8. That gives me 24, right? Factors of 24 that subtract, right, to give me negative 10. Factors that give me negative 10 of 24. Yeah, so 2 and 12 will give me a 10 if I subtract. Which one needs to be negative? I need a negative 10. Negative 12, positive 2, okay? All I'm doing is rewriting my middle term to those. I keep my 3x squared the same. I say plus 2x minus 12x minus 8. Keep your 8 the same. Factor by grouping, all right? Factor by grouping. I just found my factors of 24. So I multiplied 3 times 8. That gave me 24. Factors of 24 that subtract, because it was a negative, to give me 10. That's 2 and 12. Specifically, I want a negative 10. So I want a positive 2, negative 12. And I'm just rewriting this to be 4 terms. Keep that the same. Keep this the same. Break him up to be the ones you just found. 2 and negative 12. When you have 4 terms, you factor by grouping. So I'm going to group here. Anytime I group after a negative, I change the last sign. All right, we're going to do it by quadratic formula too. Can I take anything out of the first group? X. So I have 3x plus 2. Can I take anything out of the second group? 12 and 8. 4. So I have 3x plus 2. When you factor by grouping, it should always look like this. The guys left in parentheses should be the same. So that means 3x plus 2 is a factor. And x minus 4 is a factor.
But you can use the quadratic formula.
We are. We'll do both ways. Set each one equal to 0. 3x plus 2 equals 0. So x is going to equal negative 2/3. Subtract your 2, divide by 3. X minus 4 equals 0. So x is going to equal 4. My two answers here are potentially negative 2/3 and 4. Negative 2/3 and 4. Now these are my possible solutions. I'm going to tell you what you have to check for here. You can have extraneous solutions for these. Remember extraneous solutions. You get the solution, but then when you plug it back in, it doesn't work. You don't have to plug these back in and solve. What you do have to do is make sure it doesn't give you something that doesn't work as far as undefined. So look at these. Remember my common denominator? Denominator. What can my denominator never be? 0. Do either of those make this denominator 0? Yes, the 4 does. So the 4 is extraneous. So my only solution here is negative 2/3. So you don't have to plug them back in and say, does it actually equal? I mean, if you want to check your work, that's what you would do. But when you're looking for extraneous solutions for these, you're just saying, does anything cause a 0 in my denominator? If it does, I actually can't use that as a solution. Okay? I'm going to show you quadratic formula at this point right here. So right here, we can use the quadratic formula if you are not good at factoring, okay? So if you are not good at factoring, you can stop right there and you can use the quadratic formula. Negative b, so negative 10, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You can still use the quadratic formula here. What is it, plus 96? Yeah, there we go. So the square root of 196 is 14. So you get 10 plus 14 over 6 and 10 minus 14 over 6. This is going to be 24 over 6, which is where I got my 4. This is going to be negative 4 over 6, which reduces to negative 2/3. So quadratic formula will always work if you're not good at factoring. Now, if you had something like, x plus 1 minus 6, then I would say x plus 3x minus 2, and let's just factor, okay? But if you're not good at doing the, method where you multiply across and factor, or you're not good at pairing them up and factoring, then quadratic formula will always work.
So now